Hey there everyone, let's check out this problem about ohms applications or Ohm's law applications. So in this problem, as you can see, it's kind of like a complicated one. There's a lot of resistors on parallel and on series. There's a voltage power supply, a battery if you will, that does not have a value, so we don't know what it is. And but remember there's one power supply only, even if we have many loops, but we only have one power supply, so we don't need to use Kirchhoff's rules to solve this problem. We only need to use Ohm's law. Okay, what is this problem? This problem tells us that we have a current that is going through the 8 ohm resistor, and this current value is 0.5 amps. Find the current that is going through the 20 ohm, this current, and find the current that's going through the 9 ohm resistor. Once you find all of this, you can find anything else, like the power dissipated. If you were given the time the current flows through one resistor, you can find the energy dissipated and all of these things that you need to know. But if you find the current, you basically solve the problem. Okay. How do we go about solving this problem? It is kind of like not easy, but the best thing to do is to start where you have most of the information. All right? Where is the most of the information? The most of the information can be found in this segment of the circuit, and it tells us that there is a current is equal to 0.5, and then the resistor is 8 ohm. What can we do with that? We can find actually that the voltage is equal to I times R, and I is 0.5 and R is 8. So multiply that with each other, you get 4 volts. So the voltage drop across here is equal to 4 volts. Okay? If the voltage drop across this one is 4 volts, look, this one is on parallel with this one, so the voltage drop across this one too, I'm going to make it in red, is also 4 volts. Alright, that's good, because if we know the voltage drop here, then we can find the current that is going through this resistor, the 16 ohm, and then from the current, let's find the current first. So I is equal to V over R. Look, we're still using only one equation, which is Ohm's law. So whenever you get stuck on these sorts of problems, remember Ohm's law, V equals IR, and you will be unstuck. Okay, so V is 4 volts and R is 16. 4 divided by 16 is 0.25 amps. That's great, because now we have this current here is equal to 0.25 amps is meeting with this current, which is what? 0.5 amps. And once they meet here, they go this direction. I'm going to make it into the blue. And what do you think this one is? So this current here now is 0.5 plus 0.25, so this current must be 0.75 amps. All right, now we actually solved the first part, which is we found the current that goes through the 20 ohm resistor, and there it is, 0.75 amps. Now we need to find the current here, this one, and I'm going to make it also in blue. We need to find the current here through the 9 ohm resistor. We don't know what it is. Okay, how do we do that? We need basically to find the voltage drop across this resistor. If we find the voltage drop across this resistor, we have the resistor's value, we can find the current that is going through it. But how do we find the voltage drop across this one? Well, look, this whole combination of resistors are just actually, you can think of them as one resistor, and if you find the voltage drop across all of this here, because it's on parallel, it should be the same voltage drop here. Now let's find the voltage drop across this whole resistor. So let's find V here, all right, across this whole combination of resistors. Well, how do we do that? Again, we're stuck, so probably it's the best thing to use Ohm's law. Okay, so we have the voltage drop across these two resistors here, which is we know that it is 4 volts. So if this was one resistor, it's going to be one resistor with 4 volts voltage drop. So let me delete all of this out and just draw one resistor with the voltage drop equals to 4 volts. Now you can find what the resistor here, because of them, the equivalent resistor here, which is 1 over 4 plus 1 over 1 over 8 plus 1 over 16, but I'm not concerned about finding the value of it. It doesn't matter. I know the voltage drop across of this one is 4 volts. Okay. Now to find the voltage drop across this one, you have to multiply the current V, the current which is 0.75. So multiply the current by 20. All right. To find the voltage drop across the 20 ohms. So 0.75 times 20 is 15 volts. That's nice because the voltage drop now across this whole circuit or sub-circuit was found to be 15 plus 4, so 19 volts. So this whole thing is equal to 19 volts. Now, this whole thing, as I mentioned, is on parallel with this thing, and it's also on parallel with the battery. So the battery, actually, we already found it. It's 19 volts. The voltage drop here is 19 volts. And the voltage drop here is also 19 volts. All right, now we found 19 volts, and we know the resistor value. We can find the current. Again, we use Ohm's law. So the current, and this is in blue, will be equal to V divided by the R9, and V here is equal to 19 volts divided by 9, and 19 divided by 9 is equal to 2.11 amps. Now we know the current here is 2.11 amps that is going through the 9 ohm resistor. Using V equals IR here, V equals IR, we can also find the current, this one, that is going through the 18 ohm resistance, because I is equal V over R, where V is 19 volts because it's all on parallel. So 19 divided by 18 for the resistor, that will give us almost 1.06 amps. Now if we know the current that is going through here 1.06 amps and the current here is going 2.11 amps, I mean we solved the problem, we finished solving it, we're just doing extra stuff now. So 1.06 plus 2.11, so we know now the current that is feeding through this loop here is equal to 3.2 or 3.17 amps, because 1.06 plus 2.11 is 3.17 amps. Okay, so we got this one here. We know that the current that is going through this loop is 0.75, and that one is 3.17. So 3.17 plus 0.75, this will give us 3.17 plus 0.75. This will give us the current through the whole circuit, or the equivalent current for the circuit. And if we do this calculation, we will get 3.92 amps, and that's the whole current, equivalent current. Okay, now we can solve for anything. If you want, for example, the power dissipated here or the energy dissipated here in a certain time, you can find all of these questions and solve them. All right, That's it for now. Thank you very much.